Imagine gazing up tonight. Instead of the familiar sight of the moon perhaps shrouded by clouds or glittering across the dark velvet sky, you are confronted with something utterly alien, something magnificent. Stretching from horizon to horizon is a vast, brilliant ribbon of ice and rock, the glorious arc of planetary rings. This is not science fiction. This is the thought experiment we are diving into today. What if our blue marble Earth suddenly found itself crowned with a majestic system of rings, perhaps even grander than those orbiting Saturn? It would be the most spectacular change in human history. It would redefine everything from our poetry to our very ability to survive. Welcome to a world where the Earth has rings. First, let us set the scene. If Earth had rings, they would not be a solid structure. Like Saturn's rings, they would be composed of countless particles ranging in size from microscopic dust grains to icy boulders the size of houses, all orbiting independently in a delicate gravitational dance. This ring system would likely extend out to tens of thousands of kilometers, anchored firmly within the gravitational zone known as the Roche limit. The sheer scale of this spectacle would fundamentally change our experience of light and shadow. The appearance of the rings would be dramatically different depending on your latitude. If you stood near the equator, the rings would appear mostly edge-on. They would look like a colossal brilliant line, a stunning stripe across the zenith. This line, though thin, would be incredibly bright, particularly at night, reflecting the sunlight and perhaps casting a weak secondary light onto the ground below. Now travel to the mid-latitudes, say London, New York, or Beijing. This is where the true celestial drama unfolds. From these locations, the rings would be angled and appear as a spectacular broad arc filling a significant portion of the sky. Depending on the time of day and the season, this arc would be utterly transformative. During the day, it would be a visible structure against the blue sky, perhaps even casting shadows. At night, it would dominate the sky, reflecting sunlight that had been filtered through its trillions of icy shards. It would essentially banish true darkness. Finally, consider the poles. From the Arctic or Antarctic, the rings would appear low on the horizon, almost like a massive wall or a curved mountain range. They would loom large and imposing, stretching horizontally across the landscape, providing a permanent glow that would drastically change the cycles of polar night and day. The visual beauty is undeniable, but as always with cosmic physics, stunning visuals come hand in hand with terrifying scientific consequences. The most significant and potentially disastrous impact of Earth having rings would be on our global climate. The rings, though spread across vast distances, are not perfectly transparent. They act like a permanent colossal umbrella, partially shading the planet below. This shading effect would not be uniform. Because of Earth's axial tilt, the shadow cast by the rings would migrate seasonally. For long periods of the year, the ring shadow would fall across specific latitude bands, creating zones of perpetual winter or at least extreme cooling. Imagine the tropics. Currently, these regions receive the most direct solar energy. But if the ring system was large enough, the shadow could continuously plunge equatorial regions into semi-permanent twilight. The absence of direct sunlight, even for a few hours a day, would radically reduce temperatures. We are talking about regions like the Amazon and Central Africa experiencing sudden dramatic drops, average temperature perhaps 10 to 15 degrees Celsius. This would be a climate catastrophe for multiple reasons. First, it destabilizes weather patterns. Temperature differences drive wind and ocean currents, disrupting the energy input into the world's most critical heat engine. The equator would trigger massive shifts in global weather systems, leading to unparalleled storms, unpredictable monsoons, and perhaps most worryingly, regional glaciations. Secondly, there is the albedo effect. Albedo is a measure of how much light is reflected. The rings themselves, made of ice, would have a very high albedo, reflecting a great deal of sunlight back into space and preventing it from even reaching our atmosphere. This cooling effect, combined with the shadow, would push certain areas, especially those persistently shadowed, towards extreme cooling, perhaps even triggering localized ice ages. Areas that are already cooler like Siberia or northern Canada might find themselves locked under permanent ice sheets simply because the ring shadow provides a constant chilling factor needed for ice to accumulate year after year. This raises profound questions about agriculture and civilization. Which regions would remain reliably warm enough to grow food? It is likely that only narrow bands outside the primary shadow zones would remain habitable, forcing massive migrations and global conflict over arable land. Beyond climate change, a ring system introduces persistent and grave logistical challenges that would cripple modern technology and travel. The primary issue is what scientists call ring rain. Rings are not static, they are constantly shedding material. Over geological timescales, this material spirals inward due to various gravitational and electromagnetic forces. While most particles are microscopic, a constant shower of fine icy and rocky dust would descend into the upper atmosphere. Currently, we worry about 1 or 2 large meteors a year. With rings, we would have a permanent barrage of tiny meteorites bombarding our upper atmosphere. This has immediate consequences for aviation. High-altitude flight, even commercial jets flying at 40,000 feet, would be regularly exposed to a far higher density of debris. Aircraft windows and even fuselages would suffer constant pitting and erosion, significantly raising the risks of structural failure. Supersonic travel and military flights would become exponentially more dangerous. The greatest victim, however, would be our space infrastructure. The presence of rings makes space travel exponentially harder and more expensive. To launch a rocket through the ring plane would be like shooting a bullet through a sandstorm at 17,000 miles per hour. Rockets would need heavy shielding against high-velocity impacts, or they would risk catastrophic failure during launch or insertion into orbit. Communication satellites, GPS navigation, and weather monitoring satellites, particularly those in low Earth orbit (LEO) and equatorial geosynchronous orbit (GEO), would be subjected to continuous bombardment. Maintaining a constellation like the ones we rely on for global internet would become economically unsustainable. Any satellite in the ring plane would have an extremely short operational lifespan, requiring constant replacement and maintenance. Furthermore, the gravitational and electromagnetic interactions between the rings and Earth's magnetic field would be incredibly complex. The charged particles from the rings could potentially interfere with radio transmissions and terrestrial communication systems, perhaps leading to frequent atmospheric electrical storms or disturbances in the ionosphere that scramble long-distance radio signals. The very concept of a space-age civilization reliant on orbital platforms would have to be completely rethought in a ringed Earth scenario. We might be forced to rely almost entirely on ground-based communications and high-frequency microwave transmission towers across continents, making global connectivity far less efficient than it is today. And finally, there is the existential threat of a ring collapse. While Saturn's rings are remarkably stable, our hypothetical Earth rings would be constantly buffeted by solar winds and our own gravitational anomalies. If a large segment of the rings were destabilized, perhaps by a collision with a large comet or a passing asteroid, the consequences would be terrifying. A massive icy boulders and rocks plunging through the atmosphere would be an extinction-level event far surpassing anything we have experienced in human history. So while the rings offer a visual spectacle of unparalleled beauty, they herald an age of ecological instability, technological regression, and constant physical danger. Our scientific speculation tells us that Earth is precisely where it needs to be, an unadorned blue sphere floating through the cosmos. The next time you look up at the dark night sky, perhaps devoid of rings, but still sparkling with distant stars, take a moment to appreciate the subtle and delicate balance that allows our world to thrive. It is a reminder that the magnificent celestial decorations we see on other planets are often magnificent precisely because those worlds are fundamentally uninhabitable to life as we know it. The silent sky is the habitable sky.